Hi, this is Geometry Lesson 2-2, Proving Lines Parallel. In this lesson, we'll be able to use angle relationships to prove that lines are parallel. New vocabulary for this lesson is flow proof. We're going to learn another way of proving. Let's start with critique and explain. Juan analyzes the diagram to see if line L is parallel to line M. His teacher asks if there is enough information to say whether the lines are parallel. So if you look at the diagram, there are some notation to tell you which angles are congruent and which are not. So is this enough information to say whether the lines are parallel? We can see that angle 2 and 3 are congruent. Angles 1 and 4 are congruent. In order for the alternate interior angles to be congruent, you need to have parallel lines, right? And a transversal that goes through those two parallel lines. And 1 and 4, what is the relationship between those two angles? They are corresponding angles. So in order for corresponding angles to have congruent angles, you need to have two parallel lines and a transversal that goes through those two parallel lines as well. So we can say, yes, if a transversal intersects two parallel lines, then alternate interior angles are congruent and corresponding angles are congruent. So you can say, we have both angle relationships here, so the lines are parallel. So part A, why is Juan's statement correct or incorrect? Can you see anything that's not true? Or do you see everything makes sense? Yeah, it's a logical statement. It's a logical argument. His statement is correct. Let's write that down and say Juan's statement is correct. He made a logical conclusion based on given information. Part B. Can you use the alternate interior angles theorem to prove that the lines are not parallel? We know how to use alternate interior angles theorem to prove lines are parallel. Can you prove that the lines are not parallel, though? Is there a way to prove the lines are not parallel? What does the alternate exterior angles theorem do? Look at the angle relationships. Vertical angles are congruent, so these two would be congruent. Alternate interior angles are congruent, so these two would be congruent. Vertical angles would be congruent again. So 4 and this angle right here would be congruent. Alternate exterior angles could be this angle 1 and this angle, right? Could you use this information to prove that lines are not parallel? Well, if they're congruent, they are parallel. They could be parallel. If they're not congruent, maybe they're not parallel, but you don't use this theorem to prove that they're not parallel. There may be other factors that could affect the lines not to be parallel. So you can't really say you could prove that the parallels are not parallel, the lines are not parallel using that theorem. Okay, so no, the vertical angles opposite 2 and 3, the vertical angles, opposite angles 2 and 3 are congruent alternate exterior angles. Okay? All right. So let's think about essential questions throughout the lesson. What angle relationships can be used to prove that two lines intersected by a transversal are parallel? start with example 1. We're going to understand angle relationships. Suppose two lines are not parallel. Can corresponding angles still be congruent? Let's look. You're going to draw two non-parallel lines, T and M, and a transversal S. Okay? T and M, they're obviously not parallel. They have an intersection point here. Draw a line L parallel to M that pass through the intersection of S and T. So S is the transversal of those two lines. Okay, now we have 4 lines in the diagram. Lines T and M, T and M are not parallel. Transversal S intersects line T and M. 120 angles corresponds with the angle formed by combining 1 and 2. Does that make sense? One plus 2 will be 120. Okay? Since line L and M are parallel, we draw a parallel line here, remember? Measure of angle 1 is 120 degrees by the corresponding angles theorem, right? By the alternate interior angle theorem, 2 is equal to x, okay? Yeah, we could say that these two angles are congruent. Because if that's parallel and that's parallel, the transversal T could have alternate interior angles that are congruent. Since measure of angle 1 plus measure of angle 2 is equal to 120 degrees plus x, we can say that measure of angles 1 and 2 added together is greater than 120. If two lines are not parallel, then corresponding angles are not congruent. So they're not congruent. Let's try number 1. Could angle 3 be supplementary to a 120 degrees angle? Explain. Do you think it could be supplementary to a 120 degree angle? Does it add up to 180 degrees? See if you can answer that by yourself. Come back when you're ready for answers. Okay, what do you think? Did you say yes or no? And how did you explain it? So first of all, if you look at the diagram, we have a triangle formed by these two lines T and S and line M, right? What do you know about the interior angle sum of the triangle? They have 180 degrees altogether. And what is the definition for a supplementary angle? They add up to 180 degrees and they form a linear pair. In order for angle 3 to be supplementary to 120, it should have an angle measure of 60 degrees, right? But that means your x must be 0 degrees when you by the triangle angle sum theorem, right? So that means your 3 cannot be exactly 60 degrees. It has to be less than that. And in order for x to be a 0 degree, that means T is the same line as M, but that is not true. So there's no way it could be a supplementary to a 120 degree angle. So how can you explain that? No. Lines S, T, and M form a triangle. The sum of the interior angles of a triangle is 180 degrees. Thus, or you can say so, measure of angle 3 plus 120 degrees with plus x degrees would be 180 degrees. So measure of angle 3 plus 120 degrees is less than 180 degrees. let me put all the notations here. Decrease, decrease, decrease. Measure of angle 3. Okay. Does that make sense? Let's look at the next page. Theorems 2.4 and 2.5 are converse of corresponding angles theorem and alternate interior angles theorem. What is a converse? Converse comes from the theorem. So converse is another theorem that you could say using the original theorem. So you cannot prove two lines are not parallel by the original corresponding angles theorem or alternate interior angles theorem, because those theorems prove the lines are parallel or if the angles are congruent. They do not unprove them. Okay? The converse, however, would be able to prove them the other way. So if two lines in a transversal form corresponding angles that are congruent, then the lines are parallel. It goes the other way. Right. So yeah, you still wouldn't be able to prove they're not parallel, but you'll be able to prove the other way, that if the angles are congruent, then it must have two parallel lines. And it's the same for converse of alternate interior angles theorem. If two lines in transversal form alternate interior angles that are congruent, then you can say that lines L and M are parallel. Let's look at example 2. We're going to write a flow proof of a theorem 2.5. What is a flow proof? In a flow proof, arrows show the logical connections between statements. But you have a chart. Okay, your reasons are shown below the statements. And you have to have an arrow, right? Or arrows. So you have a statement, and then your reason is below your statement, and then that idea leads to another statement. So draw an arrow from that. Okay? Sometimes you have two things that lead to the same thing. This is when you need a flow proof. This is when a flow proof is better than the other proofs, paragraph proofs or two-column proofs. Okay? So for example, if we're given that the angles 1 and 2 are congruent, and we want to prove that the two lines L and M are parallel, we can use a flow proof to prove it in simple steps. First of all, we can say that the angles 1 and 2 are congruent by the given information. And we know angles 1 and 3 must be congruent as well because vertical angles are congruent. So these two together can make a statement that angles 2 and 3 should be congruent by the transitive property of congruence. And we can say that lines L and M must be parallel by the converse of the corresponding angles theorem. Okay, that's a flow proof. Let's look at try number 2. You're gonna write a flow proof for theorem 2-6, the converse of the same side interior angles postulate. So it's going to be very similar to the flow proof that's shown in this example. See if you can do it by yourself. Write a flow proof by yourself and come back when you're ready for answers. Are you ready? So how do you start? We're going to start with a given information. What is the given information? So 2-6, converse of the same side interior angles postulate. It's not here yet, but it's going to come next. But you're given that angles 1 and 2 add up to 180 degrees, and you don't know if these two lines are parallel. And you want to prove that the lines L and M are parallel. Okay? So that's your That's your given information. You have two lines and a transversal, and you know that this is, if that's 1, if that's 2, wait, same side interior angles, right? So if that's 1 and that's 2, you know that measure of angle 1 plus measure of angle 2 add up to 180 degrees. That's the given information. So you're going to start with this given information. And then what else can you use in order to say, in order to prove this? So what else can you add? Let's add another angle 3. So let's say this is an angle 3. Okay? What if we use 1 and 3 together? Measure of angle 1 and measure of angle 3 would add up to 180 degrees as well because they are a linear pair. So that is a statement we could also use. Why is this possible? By linear pairs theorem. Okay. And together you can conclude to another statement that says, oh, that means angles 2 and angles 3 are congruent because they will be equal to the same equation, right? And if you solve for the equation, you can say they are congruent, right? They're both equal to 180 degrees. So if you add 1 and 2, that's equal to adding 1 and 3. But if you're adding the same thing, you can subtract the same thing, right? Subtract measure of angle 1 on both sides. And you can say measure of angle 2 is equal to measure of angle 3. So by definition, angles 2 and 3 are congruent. You can say congruent supplement angles theorem. And lastly, you can say that lines L and M are parallel. And this is converse of the corresponding angles theorem. So using that, we have just proven theorem 2-6, the converse of the same side interior angles postulate, which says if you have two angles that are the same side interior angles that add up to 180 degrees, then the lines L and M are parallel. And also theorem 2-7, converse of the alternate exterior angles theorem, says that if two lines and a transversal form alternate exterior angles that are congruent, then the lines are parallel. So all of them follow a similar logic. Okay, remember all of these converse theorems. We're going to use that in our examples now. Look at example 3. Determine whether lines are parallel. The edges of a new sidewalk must be parallel in order to meet accessibility requirements. Concrete is poured between straight strings. How does an inspector know that the edges of the sidewalk are parallel? Right? The inspector can first measure the angles of the corners of the sidewalk. So we have a measurement over here, right? That's 53 and that's 53 as well. How do we know if these are parallel lines, right? You can use the theorem. Since the two 53 angles are congruent, you can apply converse of the alternate exterior angles theorem by saying, oh, this is a transversal that goes through these two lines. And those two angles could be alternate exterior angles. And they're congruent. So that means these two lines that the transversal goes through have to be parallel. So the edges of the sidewalk are parallel. Okay? So try number 3. What is measure of angle 1? And what should angle 2 measure in order to guarantee that the sidewalk is parallel to the main street over here? And explain. See if you can do it by yourself. Come back when you're ready for answers. So what could measure of angle 1 be? It is a linear pair of 53. So 180 minus 53 would be measure of angle 1, which is 127. What about 2? Angles 1 and 2 are same side interior angles if these two are parallel, right? And so they must be supplementary, which means they add up to 180 degrees. So angle 2 must have a measure of 53, which is the same as the other two angles given. So 123, measure of angle 1 is 123. Measure of angle 2 is 53 degrees. Okay, how would you explain this? If you can solve for this but cannot explain, that's a problem. The two angles are, what are the relationship? They're same side interior angles. And they should be supplementary by the same side interior angles theorem to show that the street and sidewalk are parallel. Supplementary. Okay, we have more theorems now. Let's look at the next page. Theorem 2-8 says if two lines are parallel to the same line, then they are parallel to each other. It's like a transitive property. If this is parallel to that and that's parallel to that, they're parallel to the same line, then they're all parallel to each other. Theorem 2-9 says if two lines are in the same plane, are perpendicular to the same line, then they are parallel to each other. Does that make sense? If A and B are both perpendicular to the same line, line C, they make a 90-degree angle to that same line, then lines A and B are parallel. They're parallel. Let's look at example 4. We're going to solve a problem with parallel lines. There are a lot of parallel lines you can see in real world problems. Of course, none of them are perfect lines, really, but you can apply our theorems in real life as well. Let's look at part A. When building a gate, how does Bailey know that the vertical boards V and W are parallel? The vertical boards. We're talking about the vertical boards behind this fence. Okay, how do we know they're parallel to each other? We have some given information. Vertical board V is perpendicular to this board A. Vertical board W is perpendicular to the same board A. So using theorem 2-9, we can say, oh, they're perpendicular to the same line, so they must be parallel to each other. Part B. What should angle 1 measure to ensure board B is parallel to board A? So think about all the properties for parallel lines and the transversal. We have a transversal here. And this angle A is made from this transversal that goes through all lines A, B, C. And if they need to be parallel, what does one have to measure? Think about same side interior angle theorem postulate. You have 35 degrees angle given for this angle, and that's the same side interior angle to angle 1, which means they must be supplementary to each other. They add up to 180 degrees. So by the same side interior angles postulate, 35 plus 1, measure of angle 1 should be 180 degrees. So set up your equation for that and solve for it. You'll get 145. 180 minus 35 is 145. So if you know all these postulates, you'll know which ones should be supplementary angles, which ones should be congruent angles. Okay, so use your theorems and postulates about parallel lines to ensure some lines are parallel and to figure out some angles that are unknown. All right, looking at try number 4. You're going to try for A and B by yourself. Bailey also needs board C to be parallel to board A, so what should angle 2 measure if board C should also be parallel to all the other boards? And part B is board B and C parallel to each other? Explain with a logical reason. See if you can solve it by yourself. Come back when you're ready for answers. Okay, are you ready? So she needs board C to be parallel, and knowing that angle 1 is 145 from the previous example, right? What does angle 2 have to be in order to be parallel to board A? So we're not thinking about B, so just look at this angle. We have 35 degrees angle on this angle. We have 90-degree angle on this angle, right? Angle 2 is corresponding to which angle? If this is a vertical transversal and these two, we want them to be parallel, right? Then that's a transversal. Angle 2 is corresponding to this angle, right? So this angle has to be congruent to angle 2. But what is this angle? Because your linear pair for this angle is 90 degrees, you know this angle must be 90 degrees, right? So that means your angle 2 must be 90 degrees as well. So angle 2 is 90 degrees. How do we explain in words? Oh, where did my 90 degrees go? Explain in words. You can say that 2 lines perpendicular to the same line are parallel. That was one of our theorems, right? 2 lines perpendicular to the same line are parallel. And also that means because corresponding angles are parallel, angles are congruent. These corresponding angles are congruent. Measure of angle 2 is 90 degrees. That was 4A. What about part B? Is B and C parallel? Yes, they are. But really, how do you know? Can you reason it out? A and C are parallel, right? In order for A and B to be parallel, we saw that angle 1 has to be 145. So if you continue with the example, then you can say they're parallel because if A is parallel to B and C is parallel to A by 4A example, then we can say that B is parallel to C because they're parallel to the same line. But if we say that, oh, the example is a separate thing, if we just look at the given information here, is it enough information? No, if we just look at these information here, it is not enough information. We only have these angles. We only have 35 degrees angles between these vertical boards and line A. And we don't have enough information to say B and C must be parallel. So in that case, they're not. So if you say yes, explain that you are adding up to example 4 and try for A. If you say no, explain that with the given information, it's not enough information. So why don't we just say no? Not enough information is given in the diagram to show that they are parallel. Okay, so it really depends on your given information. All right, let's summarize our lesson. There are criteria for parallel lines. If corresponding angles are congruent, then they're parallel. If alternate interior angles are congruent, then they're parallel. If alternate exterior angles are congruent, then they're parallel. If same side interior angles are supplementary, then they're parallel. So these ones all come from the original theorems for parallel lines, right? But they're converse. So if it satisfies all of these angles, then your lines are parallel, okay? Note that only same side interior angles must be supplementary. All the other theorems say they must be congruent. So please don't get mixed that up. Same side interior angles must be supplementary. They're not congruent. All right, that was lesson 1-2 for you, 2-2 for you, proving lines parallel. If you have any more questions, please ask the teachers in the math class. Otherwise, we'll continue with the next lesson in the next video. Bye.